Allow me to introduce you to the unsung hero of the electronics world, the capacitor. Tiny, mysterious, sometimes explodes, just like your ex. What even is a capacitor? A capacitor is basically a tiny rechargeable energy hoarder, like a squirrel, but electric. It stores energy not in chemicals like a battery but in an electric field between two metal plates separated by a sandwich of insulating material called a dielectric.
Which sounds like a Star Trek villain, but in an average capacitor, it's usually a combo of ceramic, plastic, and some kind of oxidized metal goo. It's also not a literal sandwich or meant to be eaten, unless you're the kind of person who likes to lick batteries, and if so, stop.
To help visualize, picture it as metal plate, dielectric sandwich, metal plate. The dielectric doesn't let current pass, but it stores energy in the electric field between the plates. This setup lets the capacitor do what it does best: charge up quickly, hold energy briefly, then release it in a fast burst when needed.
Unlike batteries, which are in it for the long haul, capacitors are all about fast response, powering quick flashes, smoothing out signals, or helping circuits survive a split-second power dip. Imagine a battery that went on a juice cleanse and got really into intermittent fasting. That's your capacitor, all about quick bursts, zero long-term commitment. Or like a battery that does CrossFit, high intensity, short duration, explosive power, and one bad rep away from popping a gasket.
The water tank analogy. Think of a capacitor like a water tank. When the faucet, your power source, turns on, the tank fills. When the faucet shuts off, oh no! The tank releases its water to keep the flow going. Except the water is electrons. And if you drink it, you will die. Capacitors smooth out power interruptions in circuits. Without one, your light might flicker every time someone opens the fridge. With one, smooth, stable electricity, like buttered lightning. How it works? Now you know. A capacitor has two metal plates and one sandwich dielectric layer that says, "No, electrons, you shall not pass." Electrons pile up on one plate. The other side? Positively charged because it's missing electrons. Poor thing. That imbalance creates voltage and bam, you've got stored energy just waiting to burst out. Then, you give it a path, like a lamp, and the electrons flood through like they've been camped out overnight for front row seats to the glow show. And then light flashes. Circuits rejoice. You feel like a circuit sorcerer who just made electrons dance on command. But then it's empty. The charge is gone. Like a firework after the bang, or your motivation 5 minutes into assembling IKEA furniture. Where they show up, capacitors are everywhere. Inside your phone, your TV, your electric toothbrush that screams like a haunted bee. They're used for power smoothing, turning a bumpy AC signal into that sweet, creamy DC. Power factor correction. In buildings full of angry motors and high-strung machinery that also might be haunted. Starting motors, jump-starting ceiling fans, air conditioners, fridges, and possibly sentient toasters.
Danger? Yes. Drama? Always. Don't let the cute size fool you. These little devils can be dangerous, and in fact, capacitors blow up, leak, bulge, or pop pretty often, especially if overcharged, old, or poorly made. They can go from energy hoarder to energy dumpster fire, to produce one of the most visually dramatic component failures on a circuit board. Kinda like your last Tinder date, full of charge and excitement until it popped, exploded, and then ghosted you forever. And some capacitors, especially the chunky ones in your microwave, can store enough voltage to yeet you into the next life. Yes, even when unplugged. So before tinkering around with anything that contains a capacitor, always test with a multimeter. And discharge it safely using a resistor, not by stabbing it with a screwdriver. Chad, you know you're not allowed to use appliances without adult supervision anymore. In conclusion, capacitors are the unsung workhorses of every device that hasn't spontaneously combusted in your house yet. They don't ask for thanks. They just store energy, release it in a glorious millisecond, and then return to their default state, intense stillness with a lurking inner chaos. So next time your stereo doesn't explode when you hit that heavy bass drop, thank your local capacitor.
And if you ever get the urge to crack open a device and start poking around its guts, remember first, unplug it, test it, discharge it. Otherwise, congrats, your obituary now includes the phrase, while fiddling with a blender. But hey, you'd go out doing what humans do best, ignoring safety warnings. Like and subscribe for more shocking science, with a spark of humor to keep your circuits firing.